The entities in this application have policies attached to respond to some common failure cases. I'm going to show them in action. The Node.js entities have service restarter policies. These work in tandem with service failure detector enrichers, which monitor the status of the entity. So the entity publishes a service is up sensor. When this is false, the service failure detector triggers an event on the sensor monitored by the service restarter policy. The service restarter then attempts to restart the process. So for example, if the process crashes for whatever reason on the machine, the service restarter policy will kick in and attempt to restart it. We have a configuration option here, fail on recurring failures in this duration. If the service restarter policy is triggered too many times in this duration, it itself will fail and throw a more significant error. Now that's picked up by a policy on the cluster, the service replacer. When the service restarter on one of the entities indicates that, say, a node is unhealthy, for example, the whole instance has crashed, then the service replacer policy will kick in, commission a new instance, and remove the old one from the cluster. So I'm going to show these in action. We'll start with the service restarter, and I'll show it through the UI, but I'll have the browser in the background so you'll also see the effects in the web console. We have our app. We don't have our app. I need to log in to our server. So we're logged into this server. We see our app. And we have our entities on the application. So we want to monitor, say, the status of one of the Node.js members. So let's look at the children as before. So let's write a simple loop just to periodically refresh the status of one of the members of this cluster. So we have this simple process refreshing, and I'm going to do the same thing, but this time monitoring the activities running against this entity. So that's our second command running. We see at the moment a few tasks every so often, not many. Ones to check, is the service up? And you'll also see polls for the metrics that we've mentioned in a previous video. So we have these running. Let's now kill this node process by SSHing to the machine. We can find out its SSH address by consulting the SSH address sensor. So I will connect to this machine. I will find the node process and kill it. So we expect to see the service is up here changed to false, and in the browser we see that the status is on fire, and that's reflected also in the terminal. So those are the service failure detector enrichers actions. The service restarter will wait a short period to determine that it's not just a transient failure. For example, Brooklyn is unable to communicate with the instance. But eventually we'll see the policy kick in with some activity. Here we are, we have the restart action in progress. In the browser we see the service is stopping, and now it will be starting again. And indeed, eventually, we have a new node process, and we can verify that it's running by visiting its main URI. So what if the service fails too much in too short a period of time? Well, let's kill it again. Because there were too many failures within the threshold, the service restarter policy has triggered a more severe error that's been acted on by the service replacer policy. That's commissioned a new Node.js server. When this server is provisioned, it will be added to the Nginx server's targets, and the old Node.js server will be removed. While this server is on fire, the Nginx has automatically been configured to only target the healthy Node.js server. So there's a single target for the load balancer, so we won't be sending users to the unhealthy server.